Close your eyes. I want to tell you something that sounds like it should be terrifying, but is, in fact, deeply relaxing. Right now, somewhere in the Pacific Ocean, a great white shark is asleep. Sort of. Here is the thing nobody tells you about great white sharks. The thing that changes everything about how you think about them. A great white shark cannot stop swimming. Not for a second. Not for a moment. Not even to sleep. If a great white shark stops moving, it stops breathing. Its gills require water to be forced through them by forward motion. No motion means no oxygen. No oxygen means, well, the shark dies. So the shark swims. Always. Continuously. Without stopping. Day after day, night after night, year after year, for its entire life. And tonight, we are going to follow one of them through the deep, dark Pacific Ocean, for one long, slow, utterly continuous night of swimming. Welcome to Sleepy Wilds. There is nothing urgent here. Nothing that needs your attention. Just a shark, an ocean, and a particular piece of a creature that has never once in its life had the option of stopping, and has, somehow, made that work remarkably well for approximately 11 million years. Let's begin. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Nothing changed in the water around her that she had not already detected, catalogued, and found irrelevant. She swam on. The shark's swimming was continuous. It had been continuous for 15 years. It would continue to be continuous. This was simply what sharks did. The night continued. The ocean continued. The shark continued. These three facts have been true simultaneously for approximately 11 million. The shark we are following tonight is a female. This is relevant because female great white sharks are considerably larger than males. The shark is approximately 5.2 meters long. 5.2 meters. This is roughly the length of a standard parking space. Or 2.5 ping-pong tables placed end to end. Or approximately 3.5 Kevin the Pandas lying nose to tail, which is not a comparison Kevin would particularly appreciate and is not one the shark has any opinion about either. She weighs approximately 1,040 kilograms. 1,040 kilograms. For reference, a standard family car weighs approximately 1,200 kilograms. She is, in other words, almost exactly the weight of a car. A car that is also a shark. Swimming continuously. At depth. In the Pacific Ocean. She is approximately 15 years old. Great white sharks can live to approximately 70 years, making them one of the longest-lived fish species known to science. She has been swimming, without stopping, since approximately 15 minutes after she was born. She will continue swimming, without stopping, for approximately the next 55 years. Tonight is simply one more night in that continuous, unbroken journey. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Nothing changed in the water around her that she had not already detected, catalogued, and found irrelevant. She swam on. The shark's swimming was continuous. It had been continuous for 15 years. It would continue to be continuous. This was simply what sharks did. Before we go any further, let's address the obvious question. If a great white shark cannot stop swimming, how does it sleep? The answer is both fascinating and slightly absurd. Great white sharks are believed to engage in something called unihemispheric slow-wave sleep, a state in which one half of the brain rests while the other half remains active enough to keep the body swimming. You might recognize this concept. We mentioned it earlier in this series, when talking about dolphins, and barn owls, and polar bears. As it turns out, sleeping with only half your brain at a time is considerably more common in the animal kingdom than anyone who has tried to sleep through a noisy night might find entirely fair. During unihemispheric sleep, the shark essentially goes onto autopilot. The swimming continues. The gills continue processing water. The basic functions continue. But the cognitive side of the brain, the part responsible for awareness and decision-making, is resting. The shark is, in every meaningful sense, asleep. It simply does not look like it from the outside. Which is, to be fair, also occasionally true of certain humans in office meetings. Tonight, the shark is in exactly that state. Half asleep. Fully swimming. Entirely continuous. The night continued. The ocean continued. The shark continued. These three facts have been true simultaneously for approximately 11 million years. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Nothing changed in the water around her that she had not already detected, catalogued, and found irrelevant. She swam on. The ocean the shark is moving through tonight is the northeastern Pacific, approximately 300 kilometers off the coast of California, in water that is currently about 12 degrees Celsius at the surface and considerably colder below. Great white sharks are one of the very few fish species capable of maintaining a body temperature warmer than the surrounding water, a process called regional endothermy, which allows them to operate efficiently in cold water that would significantly slow down most other fish. The shark's body temperature tonight is approximately 25 degrees Celsius. The water around her is 12. She is 13 degrees warmer than the ocean she is swimming through. She is, in the most literal sense, carrying her own warmth with her through the cold dark water. There is something worth pausing on in that image. The idea of moving through a cold world while maintaining your own warmth inside you, independent of whatever temperature surrounds you. You can do a version of that right now. Whatever the night outside is like, whatever the temperature of the room, your own body is doing exactly this, maintaining its own warmth, quietly and continuously, without being asked. Let yourself feel that warmth now. The shark carries hers through the Pacific. You carry yours through the night. The shark's swimming was continuous. It had been continuous for 15 years. It would continue to be continuous. This was simply what sharks did. The night continued. The ocean continued. The shark continued. These three facts have been true simultaneously for approximately 11 million years. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Here is a fact about great white sharks that researchers took a surprisingly long time to discover, primarily because studying great white sharks up close is the kind of activity that requires a great deal of paperwork, thick metal cages, and a very specific kind of professional bravery. Great white sharks have a favorite spot. Not in the way a cat has a favorite armchair. But several long-term tagging studies have revealed that great white sharks, particularly females, return to the same specific areas of ocean at roughly the same time each year with a consistency that surprised even the researchers who had spent years studying them. One famous stretch of open ocean between California and Hawaii, approximately halfway between the two, has been visited so regularly by tagged female great whites that researchers nicknamed it the White Shark Café. Not because the sharks go there for the coffee, but because they go there, year after year, with the same reliable, unhurried regularity of someone who simply prefers a particular spot and sees no compelling reason to change. The shark we are following tonight is approximately 40 kilometers from the boundary of this area. She has been here before. She will be here again. The ocean has its regulars, the same as anywhere else. She is simply one of them, passing through her own particular version of a familiar route, on what is, for her, a completely ordinary night. Nothing changed in the water around her that she had not already detected, catalogued, and found irrelevant. She swam on. The shark's swimming was continuous. It had been continuous for 15 years. It would continue to be continuous. This was simply what sharks did. The night continued. The ocean continued. The shark continued. These three facts have been true simultaneously for approximately 11 million years. The shark's swimming speed tonight is approximately 3.2 kilometers per hour. 3.2 kilometers per hour. This is slow. To put this in perspective, the average human walking pace is approximately 5 kilometers per hour. The shark is moving through the Pacific Ocean more slowly than you walk to the kitchen. Great white sharks are capable of short bursts of speed up to approximately 56 kilometers per hour when actively hunting, making them one of the faster predators in the ocean. But right now, tonight, cruising through the dark water in her half-sleep state, she is taking her time in a way that would be unremarkable in a tortoise. This matters more than it might seem. The great white shark's reputation, built over decades of films and headlines, is of something fast, urgent, relentless. The reality, on most nights, is 3.2 kilometers per hour. Slow, continuous, and utterly unhurried. Which is, as it happens, exactly the pace this story will be moving at for the rest of the evening. Let your own pace settle to match it now. Not 3.2 kilometers per hour exactly. Simply slow. Simply continuous. Simply the rhythm of something that has been doing this for a very long time and has long since stopped finding it anything other than ordinary. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Nothing changed in the water around her that she had not already detected, catalogued, and found irrelevant. She swam on. The shark's swimming was continuous. It had been continuous for 15 years. It would continue to be continuous. This was simply what sharks did. The water the shark is moving through at this depth, approximately 30 meters below the surface, has a quality that is very difficult to describe in terms that do justice to how it actually feels to be inside it, which is something you and I will never experience directly and the shark has never experienced any other way. The light that reaches 30 meters down in the Pacific at night is essentially zero. Not dim. Not dark the way a room is dark when the lights are off. Zero. The absence of light so complete that there is genuinely nothing to see, in the way human vision understands seeing. And yet the shark is entirely at home. Her vision, while adequate in shallower and better lit conditions, is not her primary sense in these depths. What guides her through the dark is something considerably stranger. Along her entire body, from snout to tail, runs a system of sensory organs called the lateral line, a series of fluid-filled canals just beneath the skin that detect the faintest pressure changes in the water around her. She feels the shape of the ocean around her. She feels the presence of things before she can see them, hear them, or smell them. She feels the water itself, its currents and eddies and the tiny disturbances left by anything that moved through this part of the ocean in the past few minutes. She is, in a very real sense, reading the dark. The night continued. The ocean continued. The shark continued. These three facts have been true simultaneously for approximately 11 million years. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Nothing changed in the water around her that she had not already detected, catalogued, and found irrelevant. And then there is the electroreception. This is where great white sharks depart entirely from anything in most people's sensory experience, into something that begins to sound less like biology and more like science fiction. Clustered around the shark's snout is a series of small pores, barely visible to the naked eye, called the ampullae of Lorenzini. These organs detect electrical fields. Specifically, they detect the bioelectric fields generated by the muscle contractions of other living animals. Everything alive generates a tiny electrical field when it moves. Every heartbeat, every breath, every twitch of a sleeping fish somewhere in the dark water ahead. The great white shark can detect electrical fields as weak as 5 billionths of a volt per centimeter. 5 billionths of a volt. To give this some context, a standard AA battery produces 1.5 volts. The shark can detect a field approximately 300 million times weaker than that. She is not simply swimming through the dark Pacific Ocean. She is reading the electrical signatures of every living thing within range, a continuous, silent, utterly invisible map of everything alive around her. Tonight, most of what she is detecting is small, distant, and irrelevant to her current half-asleep state. She registers it anyway. She always does. The shark's swimming was continuous. It had been continuous for 15 years. It would continue to be continuous. This was simply what sharks did. The night continued. The ocean continued. The shark continued. These three facts have been true simultaneously for approximately 11 million years. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Let's pause here, 8 parts into our evening with the shark, to take stock of what we have learned so far. She cannot stop swimming. She sleeps with half her brain. She is the temperature of a warm afternoon even though the water around her is cold. She feels the ocean with her entire body through a system of pressure sensors running from nose to tail. She can detect the electrical field of a heartbeat through hundreds of meters of dark water. And she is doing all of this right now, tonight, at 3.2 kilometers per hour, in the dark, in the Pacific, on what is for her a completely unremarkable Tuesday. Or Wednesday. The shark does not know what day it is. The shark has never known what day it is. The shark would, if capable of having any opinion about the concept of days of the week, almost certainly find the entire system unnecessary and probably a little overcomplicated. But the point is this: everything we have described so far, the swimming, the half-sleep, the electroreception, the lateral line, all of it is happening simultaneously, continuously, automatically, without the shark needing to think about any of it. Her body simply does it. The way your body, right now, is breathing, and circulating blood, and regulating temperature, all without you needing to manage a single part of it. You are also, in your own way, doing several extraordinary things simultaneously, right now, in the dark. You are simply not required to be aware of any of them. Nothing changed in the water around her that she had not already detected, catalogued, and found irrelevant. She swam on. The shark's swimming was continuous. It had been continuous for 15 years. It would continue to be continuous. This was simply what sharks did. The night continued. The ocean continued. The shark continued. These three facts had been true simultaneously for approximately. The shark turned slightly to the south at approximately 9:47 in the evening. Not sharply. The turn was barely perceptible as a turn at all, more of a long, gradual arc, executed over approximately 40 seconds, that shifted her heading by perhaps 12 degrees. There was no obvious reason for the turn. Nothing in the water to the south had triggered her electroreception in any particularly significant way. Nothing in the pressure readings from her lateral line suggested anything of interest in that direction. The turn simply happened. This is more common than researchers initially expected when they began tracking shark movements via satellite tags. A significant proportion of directional changes in cruising sharks show no clear correlation with any detectable environmental stimulus. The sharks simply turn. Sometimes for reasons that become apparent later, a shift in water temperature, a distant prey signal, a response to some cue too subtle for current instruments to detect. And sometimes, apparently, for no reason that anyone has yet identified. Which is, if you think about it, something you have in common with a great white shark. You have also, at some point, simply turned. Changed direction, changed your mind, taken a different route home for no reason that seemed especially important at the time. And ended up, perhaps, somewhere you were glad to be. The shark continued south. 3.2 kilometers per hour. The Pacific Ocean continued to be very large around her. And the night, as it always does, continued. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Here is something that took marine biologists a surprisingly long time to figure out, partly because the ocean is very large and partly because nobody particularly wanted to follow a great white shark closely enough to observe it directly. Great white sharks have a preferred depth. Not in the way that you might have a preferred chair, but in a statistically significant, GPS-verified, repeatedly confirmed preference for specific depth ranges that vary depending on time of day, season, and what the shark appears to be doing. During the day, great whites tend to spend more time in shallower water, the upper 50 meters or so, where visibility is better and where their prey tends to congregate. At night, they go deeper. Sometimes considerably deeper. One tagged shark off the coast of South Africa was recorded descending to approximately 1,200 meters during what appeared to be a routine night cruise. 1,200 meters. The pressure at 1,200 meters is approximately 120 times the pressure at the surface. To put this in terms a human body can understand, at that depth, the pressure would crush an unprotected person instantly and thoroughly. The shark experienced it as a slightly longer commute. She has, in the intervening time, apparently recovered from the experience just fine. Tonight's shark is currently at approximately 40 meters, which is, by her standards, practically at the surface. She is keeping things simple tonight. The shark's skin deserves a moment of attention. From a distance, a great white shark's skin looks smooth, the way most people imagine fish to be smooth. It is not smooth. Run your hand from nose to tail along a great white shark, you would feel something very close to sandpaper. Run your hand from tail to nose, you might require stitches. This is because shark skin is covered in tiny tooth-like scales called dermal denticles, each one shaped like a miniature curved tooth, all of them pointing toward the tail, creating a surface that reduces drag in one direction while being genuinely hazardous in the other. The denticles also break up water flow around the shark in a way that significantly reduces turbulence, allowing the shark to move through water more efficiently than if her skin were smooth. This design is so effective that engineers have spent considerable time and money studying it. Swimsuits for competitive swimmers have been developed using denticle-inspired textures. Aircraft surfaces have been tested with similar structures. The technology that currently improves fuel efficiency on some commercial aircraft has its conceptual roots in the skin of a fish that has remained essentially unchanged for millions of years. The shark is unaware that she is also, in a sense, an aerospace engineer. She is unaware of most things that do not directly involve water or food. She swam on. The water temperature changed slightly at approximately 10:15 in the evening. The shark felt it immediately. Not dramatically, not in a way that changed her course or pace, simply a shift of approximately 1.3 degrees Celsius as she crossed a thermocline, one of those invisible boundaries in the ocean where water of different temperatures meets and creates a sharp horizontal divide. Thermoclines are one of the ocean's more remarkable features, invisible from the surface and yet as definite as a wall, capable of keeping different ecosystems entirely separate despite occupying the same vertical column of water. The shark crossed it the way she crossed most things. Without slowing down. Without making a fuss about it. She simply registered the change, noted, in whatever way sharks note things, that the water on the other side was slightly cooler, and continued. There is, in the shark's response to this kind of change, something worth borrowing for yourself in the quiet of tonight. The capacity to encounter a change, register it fully, and simply continue. Not ignoring the change. Not alarmed by it. Simply noting it, the way a traveler notes a change in the weather, and continuing down the same road. The thermocline passed. The water on the other side was slightly cooler. The shark was slightly cooler. She swam on. Let's talk about the shark's teeth. Not because it is the most sleep-inducing topic, but because nobody ever talks about the genuinely remarkable thing about shark teeth, which is not how sharp they are, or how many rows there are, although there are several rows, arranged in a conveyor belt system that continuously moves new teeth forward as old ones are shed. The remarkable thing is how often they shed. A great white shark can go through approximately 30,000 teeth in a lifetime. 30,000. This is a number that is both completely useless to know and somehow impossible to forget once you have heard it. For comparison, a human adult has 32 permanent teeth, total, which must last approximately 60 to 70 years if things go reasonably well. The shark replaces her entire set every 1 to 2 weeks. This means that if you found a shark tooth on a beach today, and a shark tooth on the same beach 2 weeks ago, and a shark tooth on the same beach 2 weeks before that, you could, theoretically, be finding teeth from the same shark, on the same stretch of coastline, every 2 weeks, indefinitely. The ocean, in this sense, is scattered with the shark's autobiography. Chapter 1 through 30,000, broadly speaking, filed along the seafloor. Our shark has lost and replaced approximately 1,000 teeth so far in her 15-year life. She has shown no signs of finding this inconvenient. If you are still following along at this point, you have been doing so for roughly 15 minutes of story time, and I want to acknowledge something about where you probably are right now. You are probably more relaxed than you were at the beginning. Not because the shark facts are, individually, relaxing, they are interesting, which is adjacent to relaxing but not quite the same thing, but because you have been doing something very simple for the past 15 minutes. You have been listening. Not problem solving. Not planning. Not reviewing the day or rehearsing tomorrow. Simply listening to a voice in the dark, telling you things about a fish. And that turns out to be one of the more effective routes to rest available to a human brain, which evolved to respond to storytelling with a particular kind of relaxed, receptive attention that is almost uniquely compatible with falling asleep. Your brain is doing exactly what it evolved to do, in other words. And the shark, at this precise moment, is doing exactly what she evolved to do. Which is to say, she is still swimming. At 3.2 kilometers per hour. In the dark. In the Pacific Ocean. She has covered approximately 32 kilometers since the start of this story. She would like you to know that she considers this an entirely normal amount of distance for this hour of the evening. Here is a question that gets asked about great white sharks more often than almost any other, and which has a considerably less satisfying answer than most people hope for. How smart is a great white shark? The honest answer is, we are not entirely sure, and measuring intelligence in a species with whom you cannot safely share a small space without heavy steel infrastructure between you presents certain methodological challenges. What we do know is that great white sharks have larger brains, relative to their body size, than most other fish. Their brains show significant development in the areas associated with sensory processing and, interestingly, in the areas associated with social behavior. Social behavior. Great white sharks, long portrayed as solitary hunters, have been documented forming what appear to be loose social relationships with specific individuals, returning to the same areas and showing consistent patterns of association with the same other sharks across multiple years. Researchers have observed what looks, in some contexts, remarkably like a social hierarchy among great whites gathering around whale carcasses, a consistent pecking order that suggests the sharks recognize each other as individuals and have some memory of past interactions. Our shark has her own social landscape, in other words. Other sharks she knows. Other sharks she avoids. Other sharks whose electrical signatures she recognizes from 100 meters away and whose presence prompts a very slight change in her heading. She is not alone out there. She is simply alone in this particular part of the ocean, on this particular night. The shark has a scar. It runs along her left side, beginning approximately 1 meter behind her pectoral fin and extending diagonally for about 40 centimeters toward her belly. The scar is old enough that the tissue has fully healed and paled, distinguishable from the surrounding skin only by a slight difference in texture and the absence of the typical dermal denticle pattern. How she got it is not known. Possibilities include a previous territorial interaction with another shark, an encounter with a whale whose defensive response was more vigorous than the shark anticipated, or something entirely mundane, the ocean equivalent of walking into a coffee table in the dark. Great white sharks are remarkably good at healing. Their immune systems are powerful. Their ability to recover from injuries that would be fatal to most other fish is well documented, and some researchers believe their genetics may hold clues relevant to cancer resistance and rapid wound repair in humans. The scar is simply there. Part of her history. Not something she is particularly aware of anymore, the way you might stop noticing a childhood scar after enough years have passed. She carries it the way she carries everything. Continuously. Without stopping. Swimming through the dark with her whole long history attached to her, the way we all do, whether we notice it or not. At 10:47 in the evening, the shark's half-sleeping brain shifted. Not woke up exactly. Not in any dramatic way. More of a rebalancing, the hemisphere that had been resting beginning its gradual return to fuller activity while the one that had been maintaining the swim began its own slow descent into rest. This switchover, in animals known to use unihemispheric sleep, is estimated to happen several times during an extended rest period. The shark showed no visible change during the transition. Her speed remained at approximately 3.2 kilometers per hour. Her depth remained at approximately 40 meters. Her heading, still slightly south of the course she had been on before the turn at 9:47, remained consistent. From the outside, nothing had changed. Inside, everything had shifted very slightly. One part of her resting. Another coming back online. The whole system quietly cycling through its maintenance routine while the body continued its uninterrupted passage through the dark water. Your own brain is cycling through something similar right now. The conscious part, the part that tracks and worries and plans, growing quieter. The deeper, older parts, the ones responsible for your breathing and your heartbeat and the steady, patient work of keeping you alive, taking on a larger share of the night. You do not need to manage this transition. It is already happening. The Pacific Ocean is, statistically speaking, the most significant body of water on Earth. It covers approximately 165 million square kilometers, representing roughly 46% of the total water surface of the planet. It is larger than all of Earth's land combined. If you were to remove every continent and island from the Earth and put them all into the Pacific Ocean, you would still have room left over for several more continents, should any become available. The shark is swimming through a small corner of this ocean. A very small corner. Her territory, while large by the standards of most animals, is an almost imperceptibly tiny fraction of the Pacific's total volume. She does not know this. She has no concept of the Pacific as a whole, the way you might have a concept of the city you live in without having personally visited every street. She simply knows her portion of it. The temperature patterns. The current rhythms. The places where food is more likely and the places where it is less. Her own small, intimate knowledge of a very large place. Which is, when you think about it, precisely the relationship most living things have with the world they inhabit. Knowing their corner of it well. Trusting the rest to take care of itself. Continuing. By 11 o'clock in the evening, the shark had been swimming continuously for approximately the same amount of time that most people have been asleep. She had covered, in that time, somewhere between 38 and 42 kilometers, depending on the exact consistency of her speed, which varied slightly in ways that the GPS tag attached to her dorsal fin recorded faithfully and which we are not going to enumerate individually because there are, conservatively, several thousand data points and most of them are, to be direct about it, essentially identical. She swam. She continued to swim. The data confirms this. And here, at the 20-part mark of tonight's story, with the shark still swimming and you still listening and the Pacific Ocean still being extremely large around everyone involved, this feels like the right moment to notice something. You are still here. 15 years in, this shark has not stopped once. And you, too, have not stopped. Not tonight, not any night, not for the entire span of your life. Your heart has not stopped. Your lungs have not stopped. Your body has been in continuous, uninterrupted operation since before you were aware there was an operation to perform. You are, in your own way, also doing the thing the shark does. Continuing. Quietly. Continuously. Without requiring yourself to be conscious of it. The shark swam south. The Pacific continued. And somewhere, in the long dark middle of this particular night, the difference between swimming and sleeping began to feel like a much smaller thing than it had at the beginning. Here is a fact that sounds made up but is completely true. Great white sharks glow in the dark. Not dramatically. Not in the way that certain deep-sea creatures produce their own light in the absolute blackness of the abyss. But great white sharks have been found to exhibit biofluorescence, absorbing blue light from the water around them and re-emitting it as a bright green glow that is visible to other sharks, which can see in the blue-green spectrum considerably better than humans can. This was discovered relatively recently, in 2019, when researchers placed a specially filtered underwater camera near a great white and discovered, to what one suspects was a mixture of scientific excitement and general astonishment, that the shark was glowing. The shark, for her part, was unaware that anyone considered this remarkable. She had always glowed. It had never seemed worth mentioning. The practical purpose of this biofluorescence is still not entirely understood. It may help sharks identify each other at depth. It may play a role in courtship. It may do something else entirely that researchers have not yet worked out. Or it may be, in the way that many things in nature are, simply there, a feature of the shark's biology that has persisted because it causes no harm and possibly some benefit, and which nobody asked her permission about, and which she has been quietly doing in the dark ocean for millions of years without anyone noticing until very recently. The shark, currently at 40 meters depth in the northeastern Pacific, is glowing faintly green. The Pacific Ocean is very dark at 40 meters. She is the most interesting thing in it by a considerable margin. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. Let's talk about how a great white shark actually navigates. Not just the electroreception and the lateral line, which we have already covered, but the broader question of how a shark that has no map, no GPS, no landmarks in the featureless open ocean, manages to return to the same areas year after year with the precision of someone who has been there many times before. Part of the answer involves the Earth's magnetic field. Sharks, along with several other marine species including sea turtles and some migratory fish, appear to use the planet's magnetic field as a navigational reference, detecting subtle variations in field strength and inclination that correspond to specific geographic locations. In a very real sense, the shark has a built-in compass that is also, partially, a built-in map. A compass that works in total darkness. At any depth. In any weather. Without batteries. Your phone's GPS system requires satellites, internet connectivity, and a charged battery. The shark requires none of these things and has been navigating more accurately than any technology humans have produced for approximately 400 million years. She turned slightly east at 11:14 in the evening. No phone needed. No signal required. The planet told her which way was east and she went that way. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Nothing changed in the water around her that she had not already detected, catalogued, and found irrelevant. She swam on. The shark's swimming was continuous. It had been continuous for 15 years. It would continue to be continuous. This was simply what sharks did. The night continued. The ocean continued. The shark continued. These three facts had been simultaneously true for approximately 450 million years. At 11:22, the shark slowed. Not stopped. The shark will never stop. But she reduced her speed from approximately 3.2 kilometers per hour to approximately 1.8 kilometers per hour, which is, for a great white shark in open water, about as close to pausing as the species gets without actually dying. 1.8 kilometers per hour is slower than most people's brisk walking pace. It is slower than a reasonably motivated garden snail under optimal conditions. The shark, at 1.8 kilometers per hour, was moving with the urgency of someone who has already arrived at where they were going but has not yet decided where to sit. The reason for the slowdown was not immediately apparent. Her electroreception had registered something in the water ahead, a faint biological signal, distant enough and small enough that it was clearly not a hunting opportunity. Perhaps another shark, far off, moving across her path. Perhaps a large school of fish at depth, their collective electrical fields combining into something detectable at range. Perhaps something entirely different that current instruments cannot identify. The shark slowed, assessed, and then, over the following 4 minutes, gradually returned to her cruising speed of 3.2 kilometers per hour. Whatever she had detected had been noted, categorized, and found unremarkable. She continued. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Nothing changed in the water around her that she had not already detected, catalogued, and found irrelevant. She swam on. The shark's swimming was continuous. It had been continuous for 15 years. It would continue to be. Here is something about great white sharks that challenges almost everything people think they know about them. They are not, statistically speaking, particularly interested in humans. Of the approximately 100 shark attacks recorded globally each year, great whites are responsible for a subset, and of those, the majority are what researchers classify as investigatory bites, where the shark appears to be using its mouth, the way other animals might use their nose or paws, to gather information about an unfamiliar object. The shark bites. Registers that the object is not what it usually eats. And leaves. The problem, of course, is that a great white's investigatory bite is approximately the size of a dining table and generates considerable force, making the information-gathering process significantly more alarming for the human involved than for the shark. But the intent, such as it is closer to curiosity than aggression. Great whites are, in the vocabulary of animal behavior, neophilic, which means they are drawn to investigate new things in their environment. Humans, encountered in the ocean, are new things. The shark investigates, finds them uninteresting from a dietary perspective, and moves on. Tonight's shark, 300 kilometers off the California coast, is in no danger of encountering any humans. She is in approximately the same relationship to the nearest human being as you are, right now, to someone standing in northern Canada. Aware of their approximate existence. Completely unbothered by it. The night continued. The ocean continued. The shark continued. These three facts have been simultaneously true for approximately 450 million years. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. The ocean around the shark at this hour has a quality that is very different from the ocean of popular imagination. Popular imagination fills the ocean with menace, with unseen things moving in the dark, with the sense that beneath any given surface there is something waiting, something patient, something inevitable. The reality of the open Pacific at 11:30 in the evening, 300 kilometers from anything, is considerably quieter. The water at this depth and this distance from shore holds relatively little. A few scattered fish, small and largely indifferent to the shark's presence. The occasional squid, rising from depth on the vertical migration they perform each night, ascending toward the surface to feed before descending again at dawn. And the shark, moving at 3.2 kilometers per hour. Glowing faintly green. Reading the electrical signatures of squid that are not worth pursuing. The ocean, in other words, is doing tonight what it does on most nights. Very little of dramatic interest, spread across an enormous amount of space, over a very long period of time. Which is, as it happens, exactly the kind of environment most conducive to rest. Not nothing. Simply very little, quietly, continuously, without anything in particular being required of anyone. Let that be what tonight is for you too. Very little. Quietly. Continuously. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Nothing changed in the water around her that she had not already detected, catalogued, and found irrelevant. She swam on. The shark's swimming was continuous. It had been continuous for 15 years. It would continue to be continuous. This was simply what sharks did. The night continued. The ocean continued. The shark continued. These three facts had been simultaneously. The shark made a sound. This is something most people do not know great white sharks are capable of, partly because they do not have vocal cords and partly because the sounds they produce are not sounds in any conventional sense. Great white sharks, and indeed most sharks, do not produce sounds through a dedicated sound-producing organ. What they do produce, apparently, is a kind of low-frequency vibration that travels through the water, detectable to other sharks and to sufficiently sensitive instruments, but not to the human ear under any normal circumstances. The practical function of these vibrations is not well understood. It may be another layer of communication. It may be a byproduct of swimming rather than intentional communication at all. It may be something that will make sense only once we have spent several more decades figuring out what is actually going on in the inner life of a fish that has been around since before the continents were in their current positions. For now, what is known is simply that the shark produced a vibration that passed through the water around her and faded without response. She continued swimming. The vibration, whatever its purpose, having been produced, was apparently complete. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Nothing changed in the water around her that she had not already detected, catalogued, and found irrelevant. She swam on. The shark's swimming was continuous. It had been continuous for 15 years. It would continue to be continuous. This was simply what sharks did. The night continued. The ocean continued. The shark continued. These three facts had been simultaneously true for approximately. Let your own breathing become something like that vibration now. Not a thought. Not an effort. Simply something your body produces continuously, without your involvement, passing through the air around you and fading. In. Out. In. Out. The shark has been breathing, in her own way, continuously since she was born. You have been breathing continuously since you were born. Neither of you has needed to think about it once. The shark's gills extract oxygen from water with approximately 80% efficiency under optimal conditions. Your lungs extract oxygen from air with approximately 25% efficiency, which sounds underwhelming until you consider that air is about 21% oxygen and water is only about 0.7% dissolved oxygen, so the comparison is more complicated than it first appears, and the short version is that both systems work, and both of them are working right now. And neither of them requires your conscious attention. Breathe in. The shark pushes water through her gills. Breathe out. The ocean receives it. Both of you are doing, right now, the thing you were built to do. And neither of you needs to be any more awake than you currently are to do it. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Nothing changed in the water around her that she had not already detected, catalogued, and found irrelevant. She swam on. The shark's swimming was continuous. It had been continuous for 15 years. It would continue to be continuous. This was simply what sharks did. The night continued. The ocean continued. The shark continued. These three facts had been simultaneously true for approximately 400 years. At midnight, precisely, the shark was at a depth of approximately 38 meters, heading approximately south-southeast, moving at 3.1 kilometers per hour, in water of approximately 11.8 degrees Celsius. These numbers will not mean much to you individually. They are included primarily because midnight feels like it deserves some acknowledgement, and because the numbers themselves, precisely observed and precisely stated, have a quality that is useful at this hour. They are boring in a very specific, very useful way. Not the boring of nothing happening. The boring of everything being exactly as expected. The boring of a world in which, at this particular moment, every measurement that could be taken produces a result that falls within the normal range, prompts no alarm, requires no response. Everything is fine. Everything, as far as every available instrument can determine, is completely fine. The shark is fine. The ocean is fine. You are fine. All three of you are simply continuing, at your respective paces, through the same large, patient night. Nothing is required. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Nothing changed in the water around her that she had not already detected, catalogued, and found irrelevant. She swam on. The shark's swimming was continuous. It had been continuous for 15 years. It would continue to be continuous. This was simply what sharks did. The night continued. The ocean continued. The shark continued. These three facts have been simultaneously true for approximately 450 million years. Here is the last major fact for tonight, delivered at the appropriate hour for a fact of this kind. Great white sharks are, scientifically speaking, older than trees. Not older than the species of tree you might be thinking of right now. Older than trees as a concept. The earliest sharks appeared in the fossil record approximately 450 million years ago. The earliest trees appeared approximately 370 million years ago. Sharks predate trees by 80 million years. They predate the Atlantic Ocean, which began forming approximately 200 million years ago. They predate the Rocky Mountains, the Himalayas, and the Alps. They were swimming, continuously, without stopping, while the continents rearranged themselves from their original configuration into the one you know today. 5 mass extinctions happened around them. The event that killed the dinosaurs, 66 million years ago, was survived. The ice ages were survived. Each individual shark alive tonight is, of course, not 450 million years old. But the blueprint of it, the design, the electroreception, the lateral line, the teeth on a conveyor belt, the swimming without stopping. All of that is 450 million years old. And tonight, a very small piece of that ancient, unbroken, continuously swimming lineage is making its quiet way south-southeast through the northeastern Pacific. Glowing faintly green. At 3.2 kilometers per hour. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Nothing changed in the water around her that she had not already detected, catalogued, and found irrelevant. She swam on. There is something deeply settling about that fact, if you let it land properly. 450 million years. Whatever you are worried about tonight, whatever thoughts have been circling since you lay down, they are not 450 million years old. They are, at most, a few hours old. The shark's lineage has survived everything the planet has thrown at it for longer than trees have existed. And you, too, carry within you a lineage far older than anything you are currently worried about. Your cells, your chemistry, your capacity for breath and heartbeat and sleep, these are ancient. The particular problem you are turning over right now is not. Let the ancient part of you take over for the night. It knows what to do. It has always known what to do. The shark continued south-southeast. 3.2 kilometers per hour. 450 million years of knowing exactly how to do this one, continuous, unbroken thing. The night continued around her. And somewhere in the same dark, in your own warm, still corner of the world, the night continued around you too. Simply let it. The shark's swimming was continuous. It had been continuous for 15 years. It would continue to be continuous. This was simply what sharks did. The night continued. The ocean continued. The shark continued. These three facts had been simultaneously true for approximately 450 million years. The Pacific Ocean continued to be very large around her. The shark continued to be a shark. Both facts were unremarkable. She swam on. 3.2 kilometers per hour. The dark water parted around her and closed again behind her without a sound. Nothing changed in the water around her that she had not already detected, catalogued, and found irrelevant. She swam on. We will leave the shark here. Still swimming, of course. She has not stopped. She will not stop. Somewhere in the northeastern Pacific Ocean, at approximately 38 meters of depth, heading south-southeast at 3.2 kilometers per hour, faintly glowing green, reading the electrical signatures of everything alive within range, navigating by the planet's magnetic field, breathing through gills that have not paused once in 15 years. She continues. She will still be swimming when you wake up tomorrow. She will still be swimming next week. She will, in all probability, still be swimming in the year 2075, by which point she will be approximately 68 years old and will have covered, conservatively, several million kilometers through a Pacific Ocean that will have changed considerably and which she will have adapted to, as her lineage has always adapted to everything, by continuing. Simply continuing. You have spent this evening in the company of something that has never once in its existence stopped moving, never once fully slept, never once had the option of simply lying down and letting the night take over. And yet here you are. You have that option. You have it right now. The lying down part is already done. The letting go part is the only thing left, and it requires less of you than anything else you have done today. Less than making breakfast. Less than answering a single message. Less than walking from one room to another. Simply release. The way the shark releases each breath through her gills without thinking about it. The way the ocean releases each wave onto whatever shore it reaches. The way this story releases you, now, into whatever the rest of this night holds. You have earned it completely. Every part of your ancient, continuously running, never truly stopping self has earned it. Sleep well. Good night from sleepy wilds. The shark swims on. And you, at last, can stop.